Hello, my name is Diane Nichols, and I read the article Decimal Fractions, an Important Point by Sherry Martini. I chose the topic of decimal fractions because my 6th grade students struggle with representing, comparing, and connecting to decimals. I think we all do at one point or another, possibly second-guessing our own results while figuring a tip for a waitress, or comparing the percentage discounts on two different sale items. In my classroom, I see students who view decimals as whole numbers and treat them with the same rules they were taught for whole numbers without really understanding the decimal value. In this article, Sherry points out the struggles she saw in her own classroom, where students failed to connect existing knowledge to new knowledge. She even shared that she created this environment by how she was teaching decimals, to compare the numbers as if they were whole numbers, preventing her students from creating meaning and true understanding. Research shows that students' lack of understanding of fractions has to do with being taught by procedure and not context. However, students can be taught to develop an understanding of how fractions and decimals are represented. This requires teachers to determine how students think about decimals, and it requires teachers to use tools to help reveal student misconceptions and then build on student thinking in a meaningful way. Due to her concerns about her students' decimal understanding, Sherry chose to conduct a decimal comparison test to get a sense of how students think about decimals and to identify misconceptions. She also asked students to explain their answers to get a better sense of their conceptual understanding. With this test, students were asked to compare 6/10ths to 6/100ths by drawing and labeling a number line, using 10 by 10 grid, explaining their shading on the grid, using money to explain, and then use place value. This chart shows the acceptable responses for each of the 4 different representations. She noted that the fact that unacceptable responses are much higher than acceptable responses shows that additional work is necessary. I think it is important to point out that for place value, 26% of those students did not even respond. The results of her testing showed student success varied from representation to representation. Students struggled the most with the use of number line and the idea of using place value. Most students could not show accuracy on more than 2 representations. It is important to note that all 4 of these representations are addressed in the Common Core State Standards for Mathematics. Now we will be looking at the student's behavior and thinking patterns. This student recorded 6/10ths as actually being 6/1s or a unit. And then they recorded 6/100ths as being 6/10 rods. And they justify this by explaining that the 6 is in the ones place for 6/10ths, and for 6/100ths the 6 is in the tens place. Here we have a student who correctly records the 6/100ths and the 6/10ths, however incorrectly records 15/100ths as being larger than 6/10ths. This student records 6/10ths as being equal to 6/100ths. And this student places the 6/10ths on the number line and then jumps by tens to get 0.16, 0.26, on up to 96/100ths. And then when adding the tens, instead of saying 106/10ths, they recorded as 6/100ths. Now that we have looked at the behavior patterns and mathematical thinking of her students, let's look at the implications on teachers. By relating misconceptions to representations, This helps to reduce lag time and informs teaching decisions. Understanding the misconceptions that students bring with them and what they look like enables the teacher to plan for them. Teachers can consider the following questions as they plan their instruction and decimal task. 1. What questions can I ask to find out what students are thinking and to elicit their reasoning? 2. What leading questions can I ask to guide students to change their thinking? It is important for teachers to ask students to explain their reasoning. This prompting may actually cause students to rethink their reasoning on decimals. Armed with the knowledge of students' misconceptions, the teacher can consider asking questions that can guide students to change their thinking. Keep in mind, the remedy for all misconceptions is not the same. So, what can a classroom teacher do? 1. Incorporate multiple representations in developing decimal concepts. 2. Develop and structure lessons around the least comfortable representations. In this case, it was place value and number line usage. 3. Generate class discussion around misunderstandings. 4. Build tasks around particular representations. 5. Provide explicit instruction with visuals. As you can see, with this activity, Sherry chose to have her students connect decimal value to money, to manipulatives, place value, and then to fractions. 6. Have students use area models, number lines, and place value for decimal connection. 7. Use language that emphasizes the value and relationships of decimals. For example, when using place value, hundreds, emphasize the THS. Or Sherry shared the term friendly fractions, where the fraction 3/4 is equal to the decimal 75/100. And 8. Incorporate money to highlight fractional aspect of decimal notation. Some common misconceptions. The first 3 are going to be misconceptions that are listed in the article and the book both. 1. Longer is larger. When looking at the two different numbers, a student sees 3 digits in the first number and 2 in the second and decides that the 375 thousandths is larger than the 97 hundredths. A teacher can help the student with this by allowing them to use 10 by 10 grids to shade each number and offer comparison. Shorter is larger. With the digit 4 tens compared to 97 hundredths, students decide that the 4 tens is greater value. To help students with this concept, students can create representations of these two decimals and ask themselves, is any amount of tens larger than any amount of hundreds? Internal zero. It's from the book and the article both. With this, 58 hundredths is to be lesser value than the 78 thousandths because of the zero placed in the 78 thousandths. With this, allow students to use decimal number cards, physical models, or number lines. Less than zero was listed from our book. With this, students see the 36 hundredths as having less value than the zero because there is no whole number listed to the left of the decimal point. To help students with this concept, put it in context for them and ask them, would you rather have a 0 or 50 hundredths of a dollar? Students can also use grid paper to visualize this. Reciprocal thinking, where 4 tenths is connected to the fraction 1/4 and 6 tenths is connected to the fraction 1/6, making the fraction or the decimal 4/10 bigger. To help students with this, help them to use decimal materials such as 10 by 10 grids. Equality. Students have a hard time making the connection that 3/10 is the same as 30/100. So allow them to use area models, number lines, to see that the numbers are in fact the same. And finally, from the article, it states that students have a hard time connecting money and decimal value. They do not see the decimals have a place value beyond the 2 digits to the right of the decimal. So students can use a number line to see that numbers exist beyond 2 digits to the right of the decimal. I chose to connect this article to the 8 mathematical teaching practices that support student learning, because I feel that teacher instruction can have a positive impact on students' learning. Establish mathematic goals to focus learning. In this article, Sherry assessed her students to identify their thinking on decimals and use this information to set clear goals for student learning. Implement tasks to promote reasoning and problem solving. She had students connect place value and fractions to understand decimals. Use and connect mathematical representation. By using number lines, manipulatives, area models, and multiple representation for the same value, she guided her students to contextually understand decimals. Facilitate meaningful mathematical discourse. By leading class discussion of misunderstanding, she increased students' ability to represent and connect with decimals. Pose purposeful questions. By pressing students to explain their answers, she asked them to make sense of their reasoning. Build procedural fluency from conceptual understanding. By having a clear understanding of and contextual connection to decimals, students are better equipped to perform procedural fluency. Support productive struggle from learning mathematics. The teacher deliberately used the least preferred method for representation in her classroom instruction to promote classroom discussion leading to understanding. Elicit and use evidence of student thinking. She used prior assessment and questioning to gain knowledge into students' decimal thinking. But then, during classroom instruction and task time, she also asked questions to gain insight into students' thinking to guide further instruction. As I read through Chapter 14, Developing Decimal and Percentage Concepts, and Decimal Computation, I found there to be several similarities with this article. Some of the key points that I want to implement into my classroom this fall. Multiple representations, not focusing on rules and procedures that lack in reasoning skills. Making connections rather than student memorization. Questioning, to encourage explanation of thought processes. Assessing, to guide my instruction and task planning. Class discussions, to build connections and understanding.